No, it doesn't say in the quarter.
Doesn't the host have to be the one to record?
Oh, there's recording now.
Oh, it started.
All right. And everyone see my screen?
Yes.
Yeah?
Yes.
Yes.
Okay. Hello. If I haven't met you yet, it is nice to meet you. My name is Samantha Vandegraff, and I was the 2020 summer intern for Shop A here at Walters and Wolf Glass. Throughout this presentation, I'm just going to be talking about what I did throughout the summer for my internship, and then also what I learned from you all. To get started, here are the main goals of the internship. So the main goal for my project was to automate the fabrication process for parts used in door and window assembly. Now, in order to do this, I had to learn how to program the Fadal and the UR robot, as well as learning to utilize the 3D printer to print parts and create fixtures. Next, I'm going to go over what I was actually able to accomplish during the internship. Firstly, I was able to design multiple fixtures and clamps for the Fadal using Autodesk Inventor. I was then able to take those designs and use a 3D printer to make physical fixtures in order to test, and then also the final parts that are now currently in the Fadal. I also created G-code that allowed the Fadal to mill and drill precise details rather than using it as a normal mill, basically using it as a CNC. And then I was also able to implement a new tool system to help increase the efficiency of those using the Fadal. And finally, I was able to complete the main goal of my internship by automating the system for fabricating parts by programming the robot to do the job of a person. I will go over all of these things later in my presentation, but this is just a general overview. Next, I'm going to go over the design process and basically what I was able to do for each project and how my steps were throughout it, just so you guys can kind of understand what the slides in the future mean. So first step would always be to sketch the initial design of whatever I was going to end up printing on paper. And then once I kind of decided what I wanted to do, then I would transition it into a CAD drawing so that it was 3D printable. And I did all this using Autodesk Inventor. And then step 2, I would print the initial prototype, which would be something like this, just one slot for one part, just to make sure that the fixture itself would hold and work. And then I would create G-code to actually drill the holes into it for the individual one. If all of that was successful, then I would go back into AutoCAD and create a larger fixture, mostly by just making a pattern and putting the parts next to each other in a line. And then I would go print that and then create G-code for a bigger assembly. So for mine, it happened to have 11 parts rather than just the one. And then finally, I would test the final setup. And once everything fabrication-wise was working properly, then I would go to the robot and start to code the robot for the specific part. Next, I'm just going to go over a quick timeline of basically when in the summer I was able to complete what. My first week was June 1st. I started on a Wednesday, so I only had 3 days. But that first week was mostly the introduction to the Fadal, 3D printing, and then also getting a general consensus of what my project would be and what I would have to do to get that project done. Week 2, I was able to design, print, and test the initial setup, which would be this one actually specifically, and then put it together. Then for week 4, I learned to actually code the Fadal so that I could make sure that my individual bayonet test was working. Week 5, we couldn't program the robot until the robot cart was finished. So week 5 was robot cart maintenance, making sure all the handles were on properly, making sure the drawers open and close the right way, and anything else having to do with the cart to make sure that it was able to function properly in front of the Fadal without a human having to be there. And then I also was able to edit my G-code and make sure that it was working properly. And then I also created a Fadal tool library, which I will go in detail over later. Week 6, I was able to send out the robot trays to be fabricated, which again, I will explain later. And I also spent a lot of time that week 3D printing parts for others, not necessarily for my project. And then I also completed the SOP on the Fadal tool replacement. Week 7, I learned how to actually code the robot. So Miguel and I basically spent 2 whole days in front of the Fadal, learning him teaching me how to code the robot, and us working together just to figure out the best possible way. Week 8, I was able to complete the corner block code and then move on more to my actual bayonet project. But then I also was able to do a 3D printer filament extruder SOP because that part of the 3D printer broke and we needed someone to fix it and we didn't have an SOP. So I thought, you know what, let's make one while I'm fixing it. Week 9, I actually got to start the bayonet robot code, and then the robot and the Fadal both broke within 2 days. So I ended up having to just kind of keep myself busy. So I started designing 3 separate hook lug fixtures since there's 3 separate kinds of holes that need to be drilled into it. Week 10, I wasn't here. Week 11, I was able to finish the robot code, and then basically what I did was I ran both codes fully through so that I could see where there were errors. Then I would fix the error and then start it again from the beginning just to make sure that it was running all the way through. And then I was able to make those final edits to both robot codes, not just the bayonets, but also the corner blocks. And then week 12, me and Miguel worked together on the robot setup SOP since it has changed so much since their cart is relatively new. And I was also able to finish this presentation for you all. So to start, I'm going to go over the bayonet fixture. This is my original plan with my singular one rather than the tray of 11 of them. In the left picture and the bottom picture, you can see that those are my original concept drawings. I didn't end up keeping obviously the same exact thing, but the general concept was relatively the same. You can see like my exact measurements and all that good stuff. Something to talk about too is the picture on the right is the actual prototype that I was able to print out, and it does look a little bit different than the pictures on the CAD system. That's because one, I had forgotten to put the holes, so I ended up having to add those holes in later. But it was all right because it's just the prototype anyway. And then I also rounded all of the corners because it's much easier for the 3D printer to print with speed and also accuracy when the corners are rounded. Sharper corners are just harder for it. I also do want to mention that for every single fixture and setup that you see in this presentation, I did make an assembly for all of it because I just thought it would be easier to make sure that the parts fit in it before I started printing it and wasting filament for the printer for no reason. So next I'm going to go over my full scale bayonet fixture. So once I was able to test that original one and make sure it worked, I could move on to testing the big one. Also, something you might notice in the bottom left picture is that there's kind of a different color on the right side. That is because the 3D printer has some limitations. It can only print 14 inches. So I thought the best way to do that would to be print as big of a piece as I can and then print the rest of them separately and then just screw them onto the same back plate setup. So that's why there's 2 different colors there, and that's why there's screws in weird spots because they're actually 2 separate pieces that were screwed onto one plate. You can see the assembly there that I did to make sure that all the bayonets were going to fit properly into it. And then I was able to take that final setup and code it. But next, before we get to that, I would like to talk about my bayonet clamp. In order to make that fixture that I made work, I was going to need a special clamp because the angle of the bayonets is so awkward that I needed to make sure that not only did they slide into the fixture and stay in, but when the drill came back out, it wouldn't pick up the part. So I had to make sure that my clamps had these kind of ridges in them, these divots. So you can see that in the 2 drawings on the right that are CAD drawings. And then also too, besides just the physical clamp part, I also had to make something for the hydraulic clamp pump to hold on to that part. So I basically went back and looked at Miguel's clamp for his corner blocks and kind of redrew it to fit my setup better. Also, you'll see on the picture on the far right that there are milled parts out of that angle bar, and that is because they are made to avoid the clamps that press into it, so it wouldn't basically turn the clamp like while it was being clamped, if that makes sense. I'll explain it better with another picture as well. Next, I'd like to talk about the hook lugs that I was able to get started on. I never got to actually finally test these setups, but I was able to print them and I was able to make the full assemblies for it, as well as the code for the Fadal. I just never actually got to walk over there and test it. But something interesting about the hook lugs is that there's actually a right and a left. So what I did is I went through, I CAD'd the hook lug itself first, And then I went through and drew the setup that I thought would work the best. And then after making sure that that setup worked properly, I basically took it and mirrored it and then saved it as a separate part so that I could print them separately since I'm probably for the final setup, it would have to be a bunch of rights on one and then a bunch of lefts on a different one. Something else about the hook lugs is these 3 holes are not the only holes that are there. There's actually a hole through the top that is threaded. So I had to make a setup for that as well. So on the left, you'll see my original concept drawings of it. I ended up actually being able to keep my original drawing because they fit pretty perfectly within it. But if you look at the picture in the middle, you can see that there's kind of a gap between the hook lug and the setup. So I just took that out and reprinted it. And now they fit much better. Next, I just want to talk about operating the 3D printer. I really enjoyed operating the 3D printer. I had never worked with one before I came here, and I was very excited to get to actually work with it. So I had a great time just honestly learning how to use it, learning how to fix it, how to take it apart, put it back together, and troubleshooting and all of that. So my general printer uses where I use the 3D printer to print the fixtures and then the clamps for my project. Something else that I got to do as well was print parts for others. So I was able to print a bunch of clamps for the multicam, a few battery holders, and then also some test extrusions. On the left, you'll see pictures of the 3D printer actually running. The 2 orange photos are what it actually looks like inside the 3D printing software, and it kind of shows you your 3D printing environment and exactly how and where it's going to be printed inside of that. And then the picture that's right below the word 3D printer is actually the printing settings. So because I was doing different kinds of projects and also using different types of filament, which is the plastic that goes in the 3D printer, I had to have different print settings. So for the clamps, I made the print setting fill the one that's supposed to be crush resistant, whereas for the setups, I just had a normal infill, but I raised it up a little bit so that it wouldn't get broken when the drill is going down straight into it. Next, I'm going to talk about 3D troubleshooting. So as I just explained, the settings are a lot different for the different parts that I was making. I did have quite a bit of issues with the TPU filament because it is so flexible. It's kind of difficult to work with. And the feed system that our 3D printer has gears in it. So the flexible filament would get caught up in the gear and then stuck, and then filament would just stop coming out of the nozzle. So I did have to do quite a bit of troubleshooting with that. I spoke with the Fusion 3 company, which is the 3D printer company that we use, and basically worked it out with them, ran a ton of tests, a ton of print tests to see, how we were going to be able to fix it. Those bottom 2 pictures on the right, the gray plate is actually a first layer test because they wanted me to run that to make sure the printer itself was functioning before we decided that it was the filament and not the printer that was causing errors. And then we also have, you can see my failed clamp attempts where it just stopped putting out filament about halfway through, but it really is just a filament error. So I was able to finally get a couple of clamps printed out in the end. So it's not a big deal, and at least we were able to get through it and fix it. And those are the pictures that you see on the bottom left. Those are the 2 clamps that I was actually able to print out. And then if you also look on the right, that picture of the cracked setup is one that I honestly just didn't account for how much pressure it really was going to be drilling and milling down into these holes. And so I kind of had to go back through and make that part thicker and also make the infill larger so that there's more mass and it's less likely to crack and break. Next, I'm going to talk about just setting up the Fadal for my project. The cart is relatively new and the setup for that is relatively new. So on the left, you can kind of just see where it goes in front of the Fadal. And then those 2 pictures to the right of that picture on the left are the angles that keep it to the ground. The reason that we had to do this is because the robot moves with such velocity that if we didn't have it bolted to the ground, it would roll the whole cart around or the arm would just fling off the cart. So we had to make sure that they were bolted down and it wasn't going to move anywhere. If you look at the top right, you can see my setup actually physically in the Fadal. You can see where that clamp goes over that pump and gets pushed forward that I was talking about earlier. And then if you go to the bottom right picture, you can see that my code for the bayonet fabrication physically in the Fadal screen. But on the next slide, I'm going to talk about actually coding it. So in order to code the Fadal, I had to take that original assembly that I made and then find whatever tool that I wanted, which I made a library for all those tools. So there's now a library for every single tool in the Fadal, or there's a tool in Inventor for every single tool in the Fadal. And then I was able to basically choose my tool and then choose which holes I wanted it to go in. And then the software automatically picks the fastest routes. So that is what you're seeing with those yellow lines on those pictures on the right. At first, I had decided to use a mill bit, and it was just taking so very long because it was boring every single hole, which basically means it was spinning in circles around every single hole, and it was just taking a really long time. So about halfway through the process, I decided that I was just going to switch over and use two separate drills, a 1/4-inch drill for the smaller holes and then the 3/4 drill, I believe, for the bigger holes. And then if you look on the left, that is the code that basically the CAM program outputs once you pick all your holes that you're going to drill. Next, I'm going to talk about just working with the robot, what we were able to do with it, and also what we had to do with it in order to make it work. So in order for the robot to work, we had to make a couple cart improvements. On the left, you'll just see like the general setup, but those pictures, the picture in the middle on the top is the handles that we added for people to open and close, so it'd just be easier. And then those big steel handles are for the robot, so it actually has some meat to grab onto so it can open and close the drawers. And then that bottom picture of the cord is just some cord management. The robot cart was a little bit messy, and it was just hard to figure out what cords went where and what was supposed to do what. And so I kind of just took a whole day, went through it, and organized all of the cords and had them hung up on specific hooks. And then also for the robot to work with the tray, we had to, or work with, sorry, the cart, we had to have trays. This is because the robot can tell of a pattern of where to pick things up. So if we have these trays, the robot knows exactly where to pick it up, exactly how many are in line, and it's just easier for the robot to count that way. So if you look on the top left under drawer trays, you'll see the actual tray that I made. I made 3, one for each drawer, of course. But I did have 2 that didn't work properly, and I had to redraw them and then get them cut out with the multicam and then sent over to job A. The drawing on the right and the bottom is just my CAD drawings of it before I sent it to get coded for the multicam. Next, I'm going to talk about coding the robot. Coding the robot was something new for me. It was really fun. I enjoyed it, but it did take a lot of troubleshooting. So the left fabrication is the corner block code, and then the right side is the bayonet code. If you kind of look at the words, you can see that they're very, very similar, and that's just because the cart is, one shape, and we're also only having the robot do like one specific kind of action, so for each part. So they're relatively the same. Again, as I mentioned earlier, a large part of this was just letting the program run, finding out what was wrong, and then restarting it from the beginning. So next I'm going to talk about my obstacles and solutions throughout this project. I broke quite a few bits. I think I broke 4. One of them was the largest possible bit that I didn't think that you could break. And I was told that no one has ever seen anyone break anything like that. So, for firsts, we're happy. But I was able to kind of fix that. What happened was, since the bit got bent inside of the Fadal, it kind of ripped a huge hole in my setup. Luckily, I was able to just clear the debris from that, and it still functions and still works with no issues. So that's great. Another issue that I would run into is uneven bayonet lengths. The direction that I decided to put the bayonets in the setup made the lengths of it was really important that they were the same. So because that was an issue, that's part of the reason that I decided to use that flexible filament, even though it was so difficult to work with, because it would be better and more able to hold all of those parts in place at the same time, even though they were different lengths. Next, had a lot of 3D printing errors just without filament, but after working with Fusion support, we were able to fix most of the issues and get out what I needed from that filament. Also, the Fadal Z-axis failed about 2-3 weeks ago, right in the middle of my coding process. So I basically had to call the Fadal guy, his name's Aya, to come and look at it and see what was wrong. He basically ordered a new part for us, and then when they came in to replace it, they realized that the part that they had gotten was too new for our Fadal. So then we had to order another one and then go and replace that. But we were able to get it fixed within a few days, 2 days maybe. So it wasn't too big of an issue. And then also we had some robot gripper issues. The robot gripper just stopped working at some point, but we were able to unplug it and speak with the company and troubleshoot it. And we're still currently using that robot gripper because it now is functioning properly. If you look on the right, you'll just be able to see pictures of those things that I described. You can see the broken drill bit, the Z-axis fault is on the bottom, the uneven bayonet lengths is at the top. You'll also see something I forgot to write down, but I do have notes on, is that I tried to mill the plastic because it was too large of a clamp for what I needed. But I didn't really account for the fact that milling it takes away its structural integrity. So I did have like kind of a crack right here occur. So I ended up just going back and redrawing and then reprinting the whole thing and ending up with 2 of these. And then if you also look on the right, there was some issues just with the tool length and all that. And then also the one that is very messed up on the far right is the one that the drill bit got stuck in when it broke. Next, I'm just going to show you a before and after of the bayonet setup. So on the left, you'll see the bayonet setup originally had 9 bayonets in it, and they were put sideways. And there was 9 separate printed parts within it as well. And then also you look at the cart below, and it was just a completely different cart setup. But after, you can see the top right, my setup, the bayonets are actually facing a different direction. And then if you look at the cart, you can see all those separate drawers and how they're not stacked on top of each other the way that they were before. So those are just like my before and after to show you what was changed throughout the summer that I was here. Next, I'm just going to show you the actual videos of the robot running. So if you look on the left, you'll see the quarter block fabrication running. This is just to show you that the robot knows exactly what pallet or where the pallet is and where to pick up each part. And then once that video ends, I will show you the bayonet video, which also includes the drawers being opened and closed by the robot. This just means that there really doesn't need to be a person there at all when the robot is running. So that's very convenient. And also it did take a little bit because we realized halfway through the coding that the top drawer was going to have to open a different way than the bottom drawer. But we were able to get it working and get it fixed. So it actually goes all the way through, as you can see. And the basic process is it picks up a part from the tray, puts it in the Fadal, and does that 11 times, lets the Fadal run the fabrication, and then takes the parts out and puts them in a separate box to be counted. Next, I'm going to talk about just some improvements made throughout the summer that I was able to complete myself. So before I talk about the tool system, I want to just talk about the SOPs I was able to complete. I did the Fadal tool replacement SOP. I also was able to make the 3D printer, changing the filament extruder SOP, which I spoke of earlier. And then Miguel and I worked on the robot setup and takedown SOP since it had changed so much since the previous cart was considerably different than the current one. And then if you look on the left, you'll see the new tool system for the Fadal. Previously, what you would have to do is you would have to go, okay, I'm on tool 1, and let me count backwards, like 30, 29, 28, 27. And then sometimes you would count wrong and you'd change the tool and then it'd be the wrong tool. And it just kind of seemed like it could be a better process. So I decided to change that. I just got a label maker, printed out numbers 1 through 30, and then had Jose Ledesma, one of the maintenance people, put the numbers on there for me. And then along with those numbers, I also made a library for that and then printed it out and put it up on the Fadal. So say that you needed a very specific bit, you can quickly go look at the library, find out where it is, and then you can just put it straight in the Fadal and it should pop right up, exactly the tool that you need. The library is also useful because not only does it tell you which tool is in what area, but it also gives you all of the information that you need to program it, the Fadal. So it gives you the diameter of the tool. It also gives you the number of flutes and the flute length, and also the name on the left, and then the type, so probe, mill, or drill. And I just thought that that would make it way easier for everyone in the future now. Like, you don't have to worry about it. You don't have to count which ones. You don't have to measure every single tool before you use it. So yeah. Next, I'm just going to talk about some future ideas for improvement. I think that it would be a good investment for us to put a detachable box on the robot cart for the completed parts to drop into. I think it just would be easier if it was higher up, so we're not dropping the parts so far, and then they could possibly get damaged. And also too, the box moves a lot on the ground when the parts drop into it because of just, like the force of it dropping. So I think that would be something good to look into. Also too, a monthly tool check for the Fadal. On that library that I made, it actually says when it was last updated. So Miguel and I talked about it, and we're gonna make sure that he goes through and does a tool check, make sure all the right tools are there, and then also updates the library. And then also a 3D print queue system. Currently, people just email Miguel files, and then he's expected to print them and just email them back. And I think that that system could be better. And also too, sometimes he'll print something or I'll print something and then no one comes and picks it up. So I think it would be better if there was just a better queue system for that. Everyone knows how long it's going to take and when they're going to be picked up and where and all of that good stuff. Lastly, I'm just going to be talking about my lessons learned about engineering and the industry. I did not know what lean manufacturing was before I got here, and I really do think that it will be difficult for me to work anywhere that doesn't have lean manufacturing now. I just think that it is so much more efficient to know where everything is exactly where it is, and then also know where everything belongs. As well. And I think a good part of that as well is just being able to ask people, like I could ask literally anyone, hey, where does this go? And they know exactly where it is and exactly where to guide me to go to. And I just thought that that really boosted my efficiency and my productivity, and probably does for everyone else as well. Number two, failure is important and always a step towards progress. I made quite a few small mistakes. I forgot to put the holes in my original setup. And then there was other mistakes that I made, like I tried to mill the plastic and that didn't necessarily work out all that well. But I will say that from all of these mistakes, I was able to learn something and learn how to do whatever process I was doing in a better way. So I just think that failure is very important. And also I think that no one really would get down on me when I failed. They would just be like, that's okay. Like, here's some ways to fix that. And it was really helpful for me to learn. Number three, sometimes simpler is better. I think as engineers, we sometimes, get things really complicated for no reason. And then we have to work backwards. And I think that it's much better to just start simple and then work your way towards more complicated ideas. Because if your simple part doesn't work, how will your extremely complicated part work, And then also too, using your resources. While I was here, everyone was so helpful. Everyone was constantly willing to help me out, show me how to use machines. I simply could just ask, hey, can I learn how to use that? And they'd be like, sure. And I would get taught. And I think that that was so, so valuable for me. Even like I already knew how to use the mill, but I didn't want to step on anyone's toes and just take the mill. But I asked, and they were like, yeah, sure, no worries, and just kind of supervised me to make sure I wasn't going to hurt myself. But I think using my resources was one of the best things that I was able to do here, and just not being afraid to ask questions, because I know that obviously all of you are much more knowledgeable than me in the construction department and like engineering in general. So I figured, hey, like I shouldn't be embarrassed to ask questions. I should just ask. If I don't know something, like they'll teach me. And everyone really delivered on that promise. That is pretty much all for me. Does anyone have any questions?
I'm not qualified to ask questions, but it was a very good presentation.
That was a
Thank you.
really
Very
good
good
presentation.
That was
Oh,
very,
you're
very
qualified.
good.
Amazing.
Paul's
Good
job.
qualified, don't listen to them.
I appreciate that very much.
That was very, very
That
good.
was really good.
Thanks.
Yeah, great
Got a
job,
question
Sam.
about the hole in the bayonet. Did you try drilling the smaller hole before you drilled the 3/4 hole to see if that made any improvement and the ability to drill that big hole in the bayonet?
Yes, so actually for the processes, I made sure that the smaller ones were drilled first. A large part of that also too was because of the way that the clamp was in there. It was just easier to make sure that it was lined up properly by drilling the smaller ones first. And if it wasn't, I would just stop the machine, restart it, go fix my code, and then restart it. But yes.
Good stuff.
Then we have a question from Matisse and Greg.
I was trying to do a high five. It wasn't a question, but that was amazing. Excellent job.
Thank you, Matisse.
Yeah, great job, Sam. I wrote a couple questions down, but you answered them already throughout your presentation. I do have a question though. You started in June, right?
Correct.
Wow. So just, I mean, it's August and just that short amount of time, your confidence and then the way you spoke about it all, it just grew so much and it's just great work. So
Thank you.
good job.
How
I
soon do
feel
you
as I was
graduate
able
from
to learn a
school?
lot here.
Hey, I have a question. How do you feel about your training and the mentorship? Was it hard to work with Miguel?
Miguel was very helpful. Any question I had, he was willing to answer. So I promise that it wasn't hard to work with him.
When do you go back to school?
Actually, I had class today at
wow.
noon, and I just joined online because I needed to be here for this presentation. So today, but I
When?
already moved back to San Jose, so I actually drove all the way over here this morning.
Oh, wow.
Oh,
And when do you graduate?
I'm supposed to graduate in spring of 23. I have, I believe, literally one class that I'll have to take in fall, but I'm going to see if I can walk early because I kind of just think it's ridiculous to graduate a whole semester late for a 3-unit class.
Yeah.
cool. You can walk right into Walters and Wolf. That's perfect.
Yeah, I want the first interview.
So we'll see you in
Yeah.
2023.
Oh, yes. You will be
Exactly.
hearing from me, I promise.
Nice.
Anyone have any more questions for me?
Do you recommend the program for another
Yes,
students?
I 100% would. I will say that I came into this with no expectations. I really didn't know what I wanted, and I really didn't know. I just knew that I wanted to work in a machine shop. I didn't want to sit at a desk all day. That's really the only prerequisite that I had. And then I got here and I just felt that I was able to learn so much. I really wanted to work with a 3D printer and a robot, and I got to do both in one internship. So I would definitely say yes, I would recommend this.
Awesome.
Great job. Thank you so much.
Thank you.
Thanks.
Patient.
If that is all, I can let you all get back to your actual meeting.
Get back to school.